fans of poor man's Throttle. This is Jimmy Time Man from Das Fossil Railroad, and I'm here today to talk about the IBT2 motor driver. I have used a ton of IBT2 motor drivers, and I'm going to flip my camera here. Those are all IBT2 motor drivers. The problem is the quality assurance for the IBT2 motor driver is not the best, and I receive about 10% of the boards that I receive have been bad. And I know a lot of you out there that have been using the poor man's Throttle have also experienced this. And what I want to do is create this video so that you can easily identify whether or not your IBT2 will work when hooked up to the poor man's Throttle. If the poor man's Throttle is hooked up to the IBT2 board correctly, it will work. We have 100%, or I have, there is no we, this is all me, Jimmy Time Man. I have 100% success with the IBT2 motor driver and the poor man's Throttle. So this video is to help everybody identify what a good motor driver looks like and what a bad motor driver looks like. Hopefully, this video will help you identify a bad IBT2 board before it wreaks havoc or makes you think that your installation is wrong or your wiring is wrong. So let's get started. Okay, the white wire is attached to the positive of one battery. If we follow that battery, the negative end of that battery is attached to the positive of another battery. If we follow that battery, the negative of that battery is attached to the positive of the third battery. And if we follow that, the black wire is attached to the negative of that third battery. So all three of these batteries are in series. Here you can see I've got the positive and negatives. The green wire is connected to the multimeter's positive, and the black alligator clip is hooked up to the negative on the multimeter. And you can see here that we're measuring about 4.5. These are brand new batteries, so almost 4.8 volts, which is perfect for this test. Now I'm verifying that there is no continuity between the B+ and B- ports on the IBT. You can see again the green and the black are still positive and negative on the multimeter. And if I look at the multimeter in its ohms reading setting, you can see that it's an open lead, no continuity. That's what we want. Now we're testing continuity between the VCC and ground. You can see on the board it says VCC and GND, that's VCC and ground. And the pins, the gray wire is hooked up to VCC, the black pin is hooked up to ground and hooked up to our multimeter again, and we're showing open leads. That's non-continuity, discontinuity, that's what we want. From this point on, I'm going to use a breadboard to test my connections to the IBT. This makes it a lot easier, so I can just plug pins into the breadboard. That does the connectivity for me, that sends the voltage to the appropriate pins wherever I plug in. The way a breadboard works is everything that is, you see the red wire next to the red positive on the breadboard, anything on that line from the top of the breadboard to the bottom of the breadboard receives the 4.7, 4.8 volts from my batteries here. Anything on the line that is near, anything that is on the line of the breadboard that is next to that blue, the minus, receives, that is the ground for that is connected to the 4.7 volt battery ground. And you can see here the full connectivity. The red wire goes to the red alligator clip, the white wire goes to the white alligator clip, and we've got red going to white here and the white going to black, which is negative. So we've got full connectivity. So from now on, I will show everything connected from the breadboard to the IBT. Okay, now you can see that I've hooked up additionally the black and the gray wires, which are represented by the VCC and ground. You can see here the gray wire is hooked up on the VCC pin, and the black wire is hooked up to the ground. And if you follow those wires, they connect up to my breadboard. The gray wire is hooked up to positive, and the black wire is hooked up to negative. So, and again, those positive and negative are coming from my battery through the red and the white wires. Positive is red, white is negative. Then I am hooking up you can see here, the LEN and the REN. That is left and right enable. That is left and right of the H-bridge enable pins. Those are the right enable pin is the blue, the left enable pin is the green, and those are hooked up to the breadboard, both on the positive side of the breadboard. And as I turn here, you can see that they are indeed plugged both onto the positive side. Show it from this angle too. The LEN and REN wires are hooked up to the positive side of the breadboard. Okay, now we're hooking up the power to the board, where I have the B+ terminal that is connected to the purple wire, and the B- terminal is hooked up to this gray wire here. So it's a gray and purple pair. Those come over to the breadboard, and you can see the gray wire is connected to the negative, and the purple wire is connected to the positive on the breadboard. Next, what I have here, if you look at the board, the RWPM and the LWPM, they are here I've got the RWPM hooked up to the orange wire and the LWPM hooked up to the yellow wire. And if we follow those, they are both connected to ground right now. Okay, now the red and the brown wires coming out of the M+ and M- terminals. The red is the M+, the brown is the M-. Those I have hooked up to my multimeter, however you want to pronounce it, and you can see that they are currently reading 0 volts. Okay, now a simple change of the wiring. I am taking the RWPM, the orange wire, and I moved it from the ground to the positive. Now if I look at my multimeter, you will see that it is reading 4.789 volts. Now I have swapped the RWPM and the LWPM on the breadboard. So the RWPM, the orange, is now hooked up to negative, and the LWPM, the yellow, is hooked up to positive. And if I look at my multimeter, you will see that it is now negative 4.7 volts, almost 4.8 volts. That means it's in full reverse. Okay, now for a bad IBT2 board. I have the exact same connectivity hooked up, the same wires wired up right into the breadboard, and here this is in forward motion, so the RWPM is hooked up to positive, the LWPM, the yellow wire, is hooked up to negative. And if you look here, I'm only getting 1.6 volts on this motor driver. That would show slow speed. That would be about a third of the third to a little bit more than a third of the power output of that motor. And now I just put it in reverse mode, where you can see here the LWPM is hooked up to positive and the RWPM is hooked up to negative, and I'm getting 0 volts. This is clearly a bad IBT2 driver. Now, one thing that's interesting, I have here 2 bad boards that I marked with an X and a good board. You'll notice that the good board has very prominent markings on it. The IBT2 and the HW-039 are nice and bold. On these, they're thinner lettering, doesn't look as strong and bold. And also on this one, I don't know if that is an indication of good and bad boards, or higher or worse, better or worse quality assurance, quality testing. But these two boards are definitely different than this board, and they both do not work in different ways. This board here that's not hooked up does not work at all. The one that is currently hooked up, as I showed in the previous test, that this one was able to produce about 1/3 of the voltage going in forward, and it's producing no voltage in reverse.